Today's discussion is about ambiguous grammar. If a grammar can have more than one parse tree, which generate a given string of terminals, we call it an ambiguous grammar. For a sentence id plus id times id, the grammar e produces e plus e or e times e or left bracket e right bracket or id can generate two parse trees. Starting from the non-terminal e, we can have e plus e following the first rule, and the first leftmost non-terminal e can produce id, and the second non-terminal e producing e times e, and they produce id and id, and this parse tree generates id plus id times id, and the same sentence can be generated by another parse tree by expanding the start symbol e to e times e following the second rule, and this non-terminal e generates e plus e following the first rule, and each non-terminal e produces id, id, and id. So this parse tree also generates id plus id times id. This is problematic because a string with more than one parse tree gives more than one meanings. Let's suppose we have statement producing if expression then statement, or if expression then statement as statement or other. In the grammar, other stands for any other statement. And left grammar is ambiguous because two parse trees can be generated from an ambiguous sentence if E1 then if E2 then S1 else S2. For example, the star symbol statement can be expanded to if E1 then statement, which follows the first rule, if expression then statement, and this E1, E2 are two different occurrences of the non-terminal expression, and S1, S2 are two different occurrences of statement, and this expression is replaced by E1, then statement can be expanded to if E2 then S1 else S2 following the second rule, if expression then statement else statement, and this E2 is an occurrence of the non-terminal expression, then statement S1 else S2 each match are two occurrences of the non-terminal statement else statement, and different parse tree that generates the same sentence if E1 then if E2 then S1 else S2 is possible by expanding the statement to if E1 then statement else S2, which is the second rule of this grammar, if expression, which is expands the E1 then statement, can be expanded to if expression then statement, if E2 then S1, else S2 is replaced by following the third rule, other. So this parse tree also generates if E1 then if E2 then S1 as S2. So in the case of expression false, if it's false then it is not going to execute anything because there's no else statement matching the condition false. But in the second parse tree, if the expression E1 is false, then the statement following the else condition is going to be executed, which is S2. This is called dangling else problem. There are two methods to eliminate the ambiguity. The first one is adding the following additional rule, which is match each else with the closest unmatched then. So in the earlier example, if we match this else with a closed then we don't have the dangling else problem. And the second method is that we can rewrite the dangling else grammar as the following unambiguous grammar. The interior statement, that is the statement between then and else, must be matched, so the earlier grammar can be replaced by statement producing matched statement or open statement, and matched statement can only produce if expression that matches statement as matched statement or other. So here, this else is always matched with a then, and in open statement, it can produce if expression then statement or if expression then matches statement as open statement. So this open statement, if you look at here, if expression then statement, we have if expression then statement, and if expression then statement as statement. The interior statement, which is between the then and else, is replaced by matched statement, which always the else is matched with the closed then. Else we have open statement here. So let's see an example that this grammar is not ambiguous, which cannot have more than one parse tree per sentence. So this grammar restricts the parse tree to have one parse tree for a given sentence. If E1, then if E2, then S1, else S2. So using this grammar, this else cannot be matched with this then. It always matches with the close then. So statement starting from the start symbol, statement can expand open statement, and this open statement can be expanded to if E1 then statement in which E1 is an occurrence of the expression, and statement can be expanded following the second rule of the open statement. So this statement has generated open statement following the second rule of the statement, and this open statement we have expression then statement. So from open statement, if expression then statement, and this statement we can have matched statement, and by from matched statement we have if expression then matched statement else matched statement. So if E2, which is an occurrence of expression then matched statement, and S1 following then is an other, and else, and S2 following else matches statement, we can have S2. So this parse tree generates a sentence if E1, then if E2, then S1, else S2. So this grammar is unambiguous because we cannot have two parse trees generating the same sentence. So this is all for today, and in the next video I'll be discussing left recursion. And thank you for listening.